Hello everyone, hope you all are doing well. So I am back with another Leetcode Daily Challenge and it is Leetcode number 39 combination sum. It is a medium level question and I also feel the same. So the question is you are given an array called candidates and it contain integers, unique integers. Okay, not that it contain all the unique integers and you are given a target and uh, you have to find out all the possible combination from the candidate array to make the total sum to 7. Okay, for example, if you see here 2 2 3 will make 7 and 7 alone also make 7, so there is only two possibility. So we print both of them. Okay, so you can observe that you can take any number as many time as you want. Okay, as you see the second example here, the 2 taken 4 time to make it 8. Then there is 2 3 3, then 3 5, and in the third example there are no possibilities, so you have they just return a empty vector. Okay, right. So so the constant are candidate length can go up to 30 and candidate I can contain from 1 to 200, and all the element in the candidate area are distinct as I told you earlier, and the target will be at max 10 500. Okay, so after seeing this constant you can observe that you can apply a 2 to the power n complexity algorithm, means a recursive algorithm. Okay, it is 2 to the power 30, which will be less than your 10 to the power 8, I think, and it will not give you a TLE for sure. So we can try it, and I also going to explain this method only. So basically there are if I consider this first example, there are 2 3 6 7 as an input, and you need a target of 7. Okay, you need to make a target of 7. Now now you can observe that you can take a number any as many as you want. Okay, as many time as you want. But you can also, what we can do, like, if you not need a number, like let's say you not need this 6. Okay, if you need not this, so you can skip this element completely. Okay, what I mean to say, like, if I am taking the 2 first for the first uh, number, if I am taking the 2, then I can again take the 2 accordingly after checking my sum. Okay, like if it is not exhausted the target or not. Okay, but if I am ignoring this 2, so I can proceed further. No, I need not to check if again I can take 2 or not. So there is only two possibility. If you want to take that element, and if you not want to take that element. Okay, so if you take that element, then you can again try to take that element, or you can skip to the next element. But if you are not willing to take that element, okay, so you can directly skip to it. Okay, so we have only two possibility. It will be much more clear in the code part, what I am trying to say you, but I hope you all understand this what I am saying. Like, if you are taking a number, then you can try to take that number again. Okay, like if my current index is 0, so you can again, if you take it, then you can again try to take the 0th index. But if you are skipping that element, like if you are skipping 0, okay, if you are skipping 0, okay, then you have to skip to the next element. Okay, so we have to try like this. Okay, and you only need to create this element, this target element. Okay, then so what you need a variable. Okay, so which keep track your current sum, and if your current sum is exhaust means it is greater than your target sum, then simply return, don't push that element to your answer vector. Okay, don't push that array to your answer vector. For example, if I take this 2, then I take this 3, it will be 5, and then again I just take this 3. Okay, like 2 3 3, so you can see that it is greater than 7. Okay, 8 it is. Okay, so it is greater than 7, so you need not to push this elements into your answer vector. Okay, just simply return it, because if it is greater, already greater, then uh, there is then if you proceed further also, then it will give you a greater value. So you need not to find that. Okay, you only need to find the target. So these conditions will be useless if you travel further after getting a greater value also, then it will be useless for you. Okay, you cannot use that though. So what we will do, so we just return here from here. And one more one the and another, the second condition is, if I exhausted my array, okay, then it will be, then what I'll do, then again I will return from it, because if I exhausted my array and my sum is not equals to target, then it is not possible to make that sum to the target. Okay, so you need to return from here, that part also. So when you will push your array to your answer array, okay, or answer vector, whenever you encounter, like for this example it is 2 2 3 is one of the answer. So when you encounter like my array sum is 7, means is equals to the target sum, just simply push this array into your answer array or answer vector, and just simply return from here. Why? Because if it is already 7 and you proceed further with your array, then then it will produce a number which is greater than your target. Okay, so it is useless for you. Okay, so these three condition you have to take care. Okay, so I hope you understand. Let me show you the code. Okay, so basically this is the code. We need to return a vector of vector integer. So I have taken a vector of vector integer as answer, and given a name as answer, and I taken a vector of integer which keep track of all the element of my current recursion. Okay, so I named this as OP. Then I created another function named solved, and I passed the candidate and a vector, and I just passed the target as it is, and I pass the index which indicate the current element of where we are at that point of time. Okay. And I have taken a sum which will keep track of all the elements, sum of all the element that present at this OP. Okay, OP vector. So first of all, what I have checked, I have just write down that three base condition. If my sum is equals to target, then I just simply put my that OP array into this answer array, and I just simply return it. Okay, and if my sum is greater than the target, then I return. Otherwise, if my idx is equals to candidates dot size, it means that I exhausted my candidate array, then I just simply return it. Okay, now here I just take two function call. Okay, I do two function call. As I told you, I will take one in which I just take the element. In another function call, I just take I just reject that element. Okay, so I for from here it is included. Okay, it is included, and this function call is for excluded one. Okay, so I have just simply push it inside of my OP, and I add that element into my current sum, and I just call the solve function. Okay, then when it track back, I just pop it out from the output of OP vector, because as it is a global. Okay, so we need to change the changes which I have done earlier. Okay, so as I am pushing it, so I have to pop it out. Okay, then so so basically this step is the backtracking step. Okay, this is the backtracking step where we reverse the changes that we make earlier. Okay, now I just call for exclusion part. As you can see, I just remove that element from my OP, and also I simply not add that element into the sum. I just simply call it. Okay, so here the sum is the previous sum. Okay, because I am adding the sum here when I am passing it, so it will create a temporary variable. It will not pass by reference. Okay, it is but just a pass by a value operation. So after this complete operation, it all the valid vectors are inside the answer vector, and I just simply return that answer vector. Okay, so let me run the code. Okay, so it is accepted. Let's submit it. Again, it is submitted 4 millisecond. Okay, it is the best time I have got till now. Nice one. So hope you understand all the concept, and you can try run some more test cases to get a more understanding of it. Okay, so hope you enjoy it. Thank you. Goodbye. See you tomorrow. Bye bye.